This is my Math 420 Advanced Calculus Exam 1 Superset Problem 6. Prove or give a counterexample. If a sequence a sub n is monotonically decreasing and bounded below, then it converges. So for the proof, let's assume that a sub n is monotonically decreasing and is bounded below. Well, since a sub n is monotonically decreasing, for all n's that are elements of the natural numbers, a sub n is greater than or equal to a sub n plus 1. Since a sub n is bounded below, there exists an m that's an element of the real numbers such that m is less than or equal to a sub n for all n then there also exists an L that's an element of the real numbers such that L is equal to the inf of a sub n let's let epsilon be greater than 0. Since L is a lower bound, for a sub n, L plus epsilon cannot be a lower bound. So there exists an a sub cap n, where cap n is an element of the natural numbers, such that a sub cap n is less than L plus epsilon for all little n's which are greater than or equal to cap n. You end up with a sub cap n is greater than or equal to a sub n. Well, then we can write some inequalities. So we've got L minus epsilon, which is definitely less than L, and that's less than a sub n because it's the lower bound. And a sub n is less than or equal to a sub cap n, which happens to be less than L plus epsilon. So let's remove a little bit of the stuff in between and pick out what's important to us. So L minus epsilon is less than a sub n, which is less than L plus epsilon. A little bit of algebra brings us to negative epsilon is less than a sub n minus L, which is less than epsilon. And then with the properties of inequalities, we can write the absolute value of a sub n minus L is less than epsilon. And that's for all little n's that are greater than or equal to cap n. So that lets us say, since a to the n is both monotonically decreasing and bounded below, a sub n converges. Put nice box right there. Done.